Okay, in this video I'm going to explain a little bit about decibel units. And so we're interested in understanding the units dB and also the units dBm, which are often used. Um, the units of dB are used for ratios, that is a unitless number, and dBm is used when specifying a power of a signal, typically either an electrical signal or an optical signal in units relative to the power of 1 milliwatt. And I'll explain what that means. But first let's look at just the dB scale. The dB scale is a relative scale, meaning that what you're doing is you're writing a ratio down in dB units rather than as a single number. So if I have a ratio of, and I'll speak in terms of power here. You can think in terms of the power of a signal in a wire, maybe a certain wattage of a signal in a wire. If I have a power ratio, P1 divided by P naught. So there's the power P1 and then there's the power P naught. I use naught to mean 0. This ratio can be written as a number. So maybe that ratio is 100. Maybe that ratio is 0.0001. And this is a nice example of when decibel units are often used. That is when we have a large range of power ratios. Here we have a very small power ratio of 0.0001 or 1 part in 10,000. Here we have P1 being 100 times bigger than P naught. Okay? And this is a perfect situation where we want to use dB notation. And it turns out that this ratio of 100 is 20 dB, and the ratio of 0.0001 is minus 40 dB. And I'll show you how that comes about. Basically, what you're going to do is you're going to write the 100 as 10 to the 2 power. And you're going to write the 0.0001 as 10 to the minus 4 power. And basically, the dB ratio is 10 times the exponent. Okay? And so our exponent here for the ratio 100 is 2, and so we have 20 dB. 0.0001 is 10 to the minus 4th. 10 times the exponent is negative 40. Okay? We can take any number, x, and write it as 10 to the y, like this. And if we start with x, we can calculate y by going y is equal to the log base 10 of x. Okay? And so we can always find this y value for any number x, and then we can always just multiply it by 10. So for example, if I have a ratio of 0.5, I can write that as 10 to the y, and I can solve for y as 10, or as log base 10 of 0.5. And the log base 10 of 0.5, I'm going to use this calculator here, and I will find the log function. It's the log, not the ln. So log of 0.5 is equal to negative 0.301. Okay, and 10 times that is negative 3. So if I want to convert 0.5 into a log value, I'm going to say 0.5 is equal to negative 3.01 dB. And so that's how you convert a number into decibel units. And it turns out what we're doing is we're taking, if we take the log base 10 of the value, we get the exponent. and we can multiply that by 10. So if I have a ratio R, then I can convert that into decibel units. Sometimes we put a little subscript dB on a number to mean that it has decibel units. And we can say that that ratio in decibel units is 10 log 10 of R. Okay? So let me give you a couple examples. We've already done one. If R is 0.5, then R in dB units is 10 log 10 of 0.5, which is negative 3.0 dB. Got to put the dB on it after you've converted it into decimal units. Here's another example. If R is 2, then R in dB units is 10 log 10 of 2. And I can go ahead and calculate that here also. 10 times the log base 10 of 2 is equal to 3.01 plus 3.01. Okay, and as another example, if the ratio R is 50, then the ratio R in dB units is 10 log 10 of 50, which is 10 times log 10 of 50 equals 16.989, or about 17 plus 17 dB. Finally, if I have a number R something like 0.0001, I can write that number R in dB units as 10 log 10 of 0.0001, and we know what the log base 10 of 0.0001 is. It ought to be negative 4. Let's calculate it. I'm just going to do the log now, not the 10 times. I'm going to multiply by 10 afterwards here. So there's the log of 0.0001, and I hit equals, and it's negative 4 times 10 is equal to negative 40. So that's how you do these calculations, where you take a ratio which is unitless and convert it into a dB value. So dB values are unitless also. And they help us to express ratios when we have a very large range of ratios. For example, ranging from 0.0001 all the way up to 100. And it's much easier to deal with numbers like negative 40 and 20 than it is to deal with numbers like 0.0001 and 100. The decibel scale is used probably most commonly in measuring the loudness of sounds. And we have to use a decibel scale when we measure the loudness of sounds because our ear is sensitive over a wide range of sound pressure levels in the atmosphere. In other words, there's a wide range of signal powers which our ear is sensitive to. And so, for example, you may have heard of the decibel scale of sound. Something like 30 dB is 30 or 40 dB is a quiet office, 50 or 60 dB is a conversation, 70 is getting pretty loud, 80 might be your stereo on very loud, 90 or 100 is a big rock concert, 110 will cause pain, and 120 will cause very serious pain, and even dB values above 80 or 90, I think it is, can cause you hearing loss. So that's the basic introduction to dB units, which are for unitless ratios. Next video, I'll talk about the dBm unit.